Greetings of the day, dear students. In this video, we are going to discuss about source-free RL circuit. Just before watching this video, please complete a source-free RC circuit analysis. Right now, in our target is to find out the response of I of t in a given source-free RL circuit. We will find out that I of t equals to I naught into e power minus R by L into T, and also we will discuss about the time constant tau equals to L by R, and also we will discuss about a small example in this video. Right, if you observe in source free RC circuit, we have assumed that the capacitor is having some initial voltage V0. Similarly, here also we will assume that inductor has an initial current I0. It is going to have an initial current I0, right? Now the energy stored in the inductor is given by half Li square. Just like for capacitor, we have discussed that the energy stored in the capacitor is given by half CV square. Just like inductor does not allow sudden changes in voltages, just like a capacitor does not allow sudden changes in voltages, inductor does not allow sudden changes in current. Now, with respect to the source free circuit, when the source is suddenly disconnected from the circuit, whatever the energy is stored in the inductor will be released to the resistor, or will be released to the resistor. Now if you observe in this circuit, for this LR circuit, if you apply the KVL, VL plus VR equal to 0. Voltage across inductor plus voltage across resistor is equal to 0. Right? But what about voltage across inductor? L into d I of t by dt plus voltage across resistor V equal to IR. The current flowing is I of t. So R into I of t equal to 0. Now our major focus is to solve this first order differential equation. This is a first order differential equation. Our target is to find out the solution. What will be the value of this I of t? Just like if you observe, if you are given a quadratic equation ax square plus bx plus c equal to 0, this is an equation which is equal to 0, and this equation, if it is having a solution, what is the solution? The value of x which satisfies this equation, right? The value of x will be how much? Minus b plus or minus square root of b square minus 4ac by 2a. Similarly, this is also a first order differential equation. Now what should be the value of I of t such that this equation will be satisfied? This equation will be satisfied, right? Now if you further simplify this, di of t by dt plus r by l into I of t equal to 0, right? Uh, Rearrange the terms. Take r by l into I of t towards the right hand side. So therefore 1 by I of t into di of t equal to minus r by l into dt. Taking the integration on the both the sides, integral of 1 by I of t di of t equals to minus r by l into integral dt. So it is in the form of integral of 1 by x, integral of 1 by x with respect to the dx is nothing but ln of x. That is what we have written. The limits are the initial current I0 and I of t. Now the second integration, it is in the form of integral of 1 into with respect to the time dt. So its value will be integral of 1 with respect to dt is t. That is what we have written here, minus r by l into t within the limits 0 to t. Now upper limit minus lower limit, ln of I of t minus ln of I0 equal to minus r by l into t. Now ln of some x minus ln of y. Nothing but ln of x by y. We are familiar with this basic. That is what we have written here. Ln of some x minus ln of y. So ln of uh, I of t by I naught equal to e power minus r by l into t. Right? Ln of some x base equals to y. Then x equal to x will be how much? Then x will be equal to e power y. That is what we have done here. I of t equals to I naught into e power minus r by l into t. This is very, very important. If you observe, we have derived for the capacitor, voltage across capacitor, some Vc of t equals to V naught into e power minus t by tau. If it is RC case, the tau value is equal to RC. If it is RL circuit, the tau value is equal to L by R. Very, very important. Time constant tau. For Similarly, for inductor, we got the response as I of t equal to I naught into e power minus R by L into t. Clear? Right. Now, if you plot the graph for I of t versus t, right? If you observe this term, this is exponentially decaying. E power minus is there. E power minus sign, this indicates that it is going to exponentially decrease from some maximum value I naught to it slowly comes down or reaches the value 0 within a certain period of time. Now, the time taken for the initial value to decay to the 36.8%, 36.8% of its initial value, then that time period we can treat it as the time constant tau. Clear? If initially there is some 1 amp of current, initially the current initial current across the inductor or through the inductor is 1 ampere. Now within a time period of tau, it will come down to 0.368 amps. Like that we have to understand. Now slowly it reaches the 0. And this is also possible within 5 tau time period. Maximum it reaches the steady state. It reaches the steady state. If you observe, there is no source in this circuit. So this is the natural response of the RL circuit. This is I of t equal to I naught into e power minus t by tau is the natural response. It is not the response due to some forced input. Natural response. There is no source present in this circuit, right? Now, what will be the voltage across the resistor? The current flowing is I of t. Resistor value is R. So simply V equals to IR. Now, just now we have derived I of t equal to I naught into e power minus t by tau. Therefore, the resistor, the voltage across the resistor will be I naught into R into e power minus t by tau. Minus t by tau. Power formula is VI. Power P equals to voltage across resistor VR into I of t. But I of t equal to I naught into e power minus t by tau. Therefore, the power dissipated in the resistor will be I naught square R into e power minus t minus 2t by tau. Clear? So these three equations are very, very important with respect to the source free RL circuit. Now, for example, if initially there is 1 ampere current, you are having an inductor like this, right? And you are having a resistor like this. Initially there is some 1 ampere of current, right? Now if the R value is 1 kilo ohm and if the inductor value is some 100 millihenry, now within how much time period do you think this 1 amp will become 0.368 amps? That time is nothing but tau. Tau equal to L by R. But what is the value of L? 100 into 10 power minus 3 whole divided by 1 kilo into 10 power 3. So it is equals to 100 into 10 power minus 6 seconds. So within a span of 0.0001 second, right? Within a span of 10 square, no, 10 power minus 4, 0.001 second. See, within how much short span this 1 ampere if is becoming 0.368 amps within a very short span, 0.001 second. Within that time frame, it discharges or it becomes to 0.368 amps. That is the meaning of this time constant tau. Most of the times our value of L inductance will be in millihenry, right? So don't think that it takes a long time to discharge or long time to decay this I naught value to 0. Clear? It all depends on the value of inductor value and resistor value. Okay? Yeah. Now let me discuss one example. For this given circuit, calculate I of t. The question is very simple, but if you observe, this arrow direction is important. Please focus carefully, dear students. This arrow is like this, but it is towards outside like this. Its meaning is the switch is open at time t equals to 0. So what does it mean? The instant at which it is open, from there you are taking the reference time t equals to 0. Then how do you understand this? Just before opening the switch, it is closed for a long period of time. It is in the closed state for a long period of time. Like that you have to understand. If in case if the switch is given like this, for example, observe if it is given into the at t equals to 0, if this is B case and if this is A case, in B case you have to understand it as, for example, if you are having some voltage source and here you are having some circuit, its meaning is the switch is closed at time t equals to 0. Just before closing the switch, it is open, it is kept open for a long period of time. Now be clear. Observe here the switch is open at time t equals to 0. Its meaning is just before the opening it is in the closed state for a long period of time. Now if you observe the inductor for DC input, how it behaves like while discussing the source free RC circuit for DC input, this capacitor for a long period of time, if it is input, it behaves like a open circuit, OC. Similarly, for the same DC inductor, if it is applied to an inductor, right, it behaves like a short circuit. Now, just before opening the switch, whatever the current is flowing in this short circuited path, that current will now act like a initial current. Very, very important. Dear students, please don't get confused at this point, because our target is to calculate I of t. Now I of t is we are very much clear. Now we won't start again deriving on that entire derivation. I of t equals to I naught into e power minus t by tau, or in terms of R and L, how much we got? E power minus R by L into t. E power minus R by L into t. Now in this given circuit, our target is to find out the initial current, because in the problem he has not specified the initial current. Once we know this initial current, then this problem will be very easy for us. Now what will be that initial current? That is the current just before opening the switch. Before opening the switch, the inductor is now behaving like a short circuit for DC. So whatever current is flowing in this short circuited path, that current now will act like a initial current through the inductor. Initial current through the inductor. Now in this circuit, observe dear students how we can calculate the current through this short circuited path. Once you know this total current, we can apply the current division rule. So the total current entering I1 is given by V divided by R equivalent. What is applied voltage? 40 whole divided by current is entering from this side. R equivalent we want to find from this side, from voltage source, voltage side. This 4 ohms and 12 ohms are in parallel. That is what we have written, 4 parallel to 12, and the resultant will be in series with 2 ohms. 2 plus 4 parallel to 12. Clear? Now number of times we have discussed, if two resistors R1 and R2 are in parallel, what is the R equivalent value? R equivalent value is R1 into R2 divided by R1 plus R2. That is what we have done here. 4 parallel to 12. R equivalent will be how much? 4 into 12 by 4 plus 12. So 2 plus 3. Now the answer is 40 by 5 equal to 8 amps. But dear students, observe that is the current entering just here, 8 amps. 8 amps is entering here. Now how much current will flow through the 4 amps? That is our area of interest. To get the initial current through the inductor, we want the current through this short circuited path. Now current through this short circuited path is nothing but the current through the 4 ohms. But just now we have calculated the total entering current is 8 amps. How much current will flow in these 4 amps? Simply we can apply the current division rule. From current division rule, right? If two resistors are there, R1 and R2, and if you are having here, if there is some 8 amps is entering at this point, if current in R1 is I1, if current in R2 is I2, then how I will get I2? I2 is nothing but total current into opposite arm resistance. While calculating I2, what is the opposite arm resistance? R1 divided by what is the total resistance? R1 plus R2. Clear? So that is what we are doing here. Now I want current through 4 amps. So I1 into opposite resistance. For 4 ohms, what is the opposite resistance? 12 ohms. 12 divided by 12 plus 4. So 8 into 12 by 16 equal to 6 amps. Therefore, dear students, the initial current through the inductor just before closing the switch, just before opening the switch, 0 minus, it does not mean that the time is negative. Inductor does not allow sudden changes in current. That is the reason why whatever the current that is flowing just before opening will be existing immediately after opening also. That is the reason we write here I0 minus is also same as I0. If you observe for capacitor, we have written VC 0 minus is also same as VC 0. For capacitor, we have done that, right? Yeah. Now the initial current is 6 amps. The major part is completed. If in the problem itself initial current is given, now this much thing will not come into the picture. Clear? Yeah. Next target is in this formula R by L, which R you have to write. So many resistors are there. Then here the student feels the difficulty. Whether it is 12, 4, 16 or 2 or what we have to write. L is clear, 2 Henry. This is nothing but R equivalent or equivalent. Now what will be the R equivalent? Dear students, keep in mind the R equivalent is to be calculated after the switch is open. Then once the switch is open, now this voltage source and this 2 ohms will not come into picture. You can remove this part. 40 volts and 2 ohms, we can remove that part because the switch is open. Now there is no use of this 40 volts and 2 ohms. For the remaining part, calculate the R equivalent. That is important. This is the point where student feels the difficulty. He will stuck up here. Through somehow he will calculate current I naught. Now after calculating the current I naught, now he want to calculate the tau. Tau equals to nothing but L by R equivalent. But while calculating R equivalent, observe the part of the circuit here that is existing is removed. This part is removed. Now for this 12 ohms, 4 ohms, 16 ohms and 2 Henry, what will be the resultant? Observe these 4 ohms and 12 ohms are in series. 4 ohms and 12 ohms are in series. The resultant is in parallel with 16. 12 plus 4, 16 parallel to 16. So the answer is AB by A plus B, 16 into 16 by 16 plus 16. The answer is 8 ohms. Therefore, R equivalent is how much? 8 ohms. Now the problem is simplified. Tau equals to L by R equivalent. L is 2 Henry, 2 by 8, nothing but 1 by 4 seconds is nothing but 0.25 seconds. Therefore, in the final equation, the solution of the first order differential equation I of t equals to I naught into e power minus t by tau, right? I naught we have derived and we have calculated, its value is 6. Tau value just now you have calculated, its value is 0.25 second. Therefore our I of t will be 6 into e power minus 4t. If you plot the graph I of t equals to 6 into e power minus 4t for the given problem, you can see its magnitude at different values of time. For example, I have just tabulated for some values. At time t equals to 0, e power 0, 1, anything power 0, 1. 6 into 1, 6. At time t equals to 0, the value of current is 6 amps. Observe at 0 second, the magnitude is 6 amps. Now at time t equals to 1 second, in the place of t, I have taken 1, e power minus 4 into 6. So 0.109, 0.109. But I have taken within the 0 to 1 second, so many values are missing. So what I have done is, I have taken some more values between 0 to 1. I have observed 1.25, 0.25, 0.5, 0.75. For those values, we are getting current like this. For 1.25, 0.04. For 0.25, 2.2. For 0.5, 0.81 amps. At 0.75, 0.29 amps we are getting. Right? If you join all those points, you will get a shape like this. Observe the current is exponentially decaying with increase in the time period. And slowly it is reaching or approaching the value 0. Within how much time period do you think this will reach the steady state? Within 5 tau. But what is tau in our case? In our case the tau is 0.25 second. How do you understand this 0.25 second? At t equals to tau, the magnitude 6 will become now 36.0.36. What is the percentage? 0.368, 0.368, 0.368 amps will be our magnitude at time t equals to tau. At t equals to tau, in this problem tau is 0.25 seconds our magnitude will be 0.368 times the initial value. Initial value is 6. So how much it will becomes? 6 into 0.368. Now it becomes 2.208 amps. 2.208 amps. Like that we have to understand. Clear? Yeah. Now this is all about the time domain analysis of source free RL circuit. Dear students, out of this entire discussion, the major key points are: this is the first order differential equation. This equation will have the solution. The solution of the equation is I of t equal to I naught into e power minus r by L into t. I naught is the initial value of the current, right? Now, time period tau is defined as the time taken for the initial value to decay to the 36.8% of its initial value. That time we can take it as the tau, and that value will be equals to the time tau equals to L by R. Now I of t is given by I naught into e power minus t by tau. This is the natural response, right? If you have taken a small example, 1 ampere, if this is the initial current I naught across the inductor, and the value of inductor L is 100 millihenry, R is 1 kilo ohm, within a time span of L by R, nothing but 100 into 10 power minus 3 by 1 into 10 power minus 1 into 10 power 3, that is nothing but 0.001 second. Within this time period, this 1 ampere will become 0.368 amps, right? Yeah. Now we have discussed the example. If initial current across the through the inductor is not given, then uh, in this problem it is not given, right? We have to calculate, because we know the total response I of t equal to I naught into e power minus r by L into t, right? We have calculated the I naught, nothing but the current flowing through this short circuited path, because in DC, if it is applied to the inductor, okay, uh, it behaves like a short circuited path in the steady state, right? Yeah. Now the current we have calculated. Clear? This is what we have done. Now, in this R by L, R is nothing but the R equivalent. R equivalent. R equivalent, how we have calculated? After opening the switch, this is the remaining part of the circuit. For this circuit, we have calculated the R equivalent. In the place of tau, L by R equivalent, we have to write. If one resistor is given, only one resistor only given, then that is not a problem. But here, so many resistors are there. Combination is there. So, we have to calculate the R equivalent, right? So this is how we can do this problem, right? Thank you.